Okay guys, so today we are going to be talking about graphing piecewise functions. So basically what that means is that you have a function until a certain point, and then you have another function, and then they just kind of change. So for us, for number 1, we're graphing this graph until we get to 2. So 2 is here. And then this is going to be our shift for our x value. And then it's going to be different from the left and then the right. So I like to make a table of values. And I'm going to just pick some numbers so I have an idea of what the line looks like. So like -6, -4, -1, and then I also want to pick 2. But this is going to be kind of like my tipping point because it's a shift on the line. And we're going to talk about that. Okay, and then I also want to pick numbers as well for my other function. So I'm going to start with 2 again, because again, that's like my tipping point. So this is where my shift is, so I need to know what 2 is for each of these, so I know where to put the dot. And then I'm going to pick some other numbers, like just 6. I'd pick more, but the function of this is pretty easy. It just means that for every x value, your y value is going to be -3, so these are all -3, which means we have a horizontal line, and the same thing happens with our next graph. We have -2 and -2. This just gives an idea of what a piecewise function actually looks like. So I'm going to put these dots on my graph because that's good practice for later. So -6, and then we have -1, 2, 3, -4, -3, -1, -3. Now, before we put our dot on our 2, when I look at my inequality, it is not filled in. So when I put my dot on my graph, I need to have an open circle, because it doesn't include that. It's all of these cute little baby numbers up to it, but not that number, because the inequality doesn't have a line. However, on the next one, I do have a line. So at 2, -2, I want to make sure that line is solid. And then I have a dot at 6, -2. So it gives you an idea of what the lines look like. Okay, so the next thing I'm going to do is I'm going to graph my lines. So I have a line going off to the left and then off to the right. I said those backwards. Oh my gosh! What the heck did I do? Okay, sorry about that. That's bananas looking. Okay, anyways, can't fix it. So that's what your graph should look like when you graph it. These dot and this dot don't always connect. Sometimes they do, but a lot of times they don't. Okay, so let's try another example. Nice long table. Okay, so I have numbers that are smaller than 1. My x value is smaller than -1. Sorry, not 1, -1. So I'm going to pick some guys on here. So like, give me a picture of what this looks like. -8, -4, and then I'll put -1. Again, that's my pivot point, and I also want to put -1 there as well. And then I want numbers bigger than -1, and I need to get an idea of what this picture is going to look like. So like 2, 6, 8, that's an idea. All right, so we're going to plug our number in. So -8 with the negative makes a +8, plus 1 is 9. -4 with this negative is a +4, plus 1 is 5. -1 with this negative is a +1, plus 1 is 2. Then down here I have -1 minus 1 is -2. 2 minus 1 is 1. 6 minus 1 is 5. 8 minus 1 is 7. So now I've got some ordered pairs. And again, on this inequality, because it's not equal to, I need to have an open dot. But the next one is closed dot. Okay, so we have -8, 9, which is a tiny bit off the grid. It's totally fine. And then we have -4, 5, so -4, 5. So again, my cute little shift occurs at -1, so I want to be mindful about that. And then we have -1, 2, and again it's going to be open because it's not or equal to. It doesn't have the line underneath. Okay, so there's that line. That's half of my picture. And then I'm going to graph the rest. This guy is a closed dot because of that cute little line. So we've got -1, -2, 2, 1, 6, 5, 8, 7. Okay, so now I have an idea of what this line looks like as well. Okay, and there's my piecewise function. That's so cute. Love it! It looks kind of crazy, huh? Okay, let's keep going. Okay, number 5 is really similar to those other ones at the beginning. So we just have our x and our y values. We have a shift happening. Oh no. We have a shift happening at +1. We're going to have basically the two graphs come together. So we want some numbers that are smaller than 1. So -6, -4, and then we could pick 1. 1 again, and then 4, 6, sure, why not? Okay, and remember for every y value, because these are just plain numbers, that's what or for every x value, my y values are these. So we've got 6, 6, 6, -6, -6, -6. This guy has a closed dot, this guy has an open dot. Oh, good heavens. Okay, so -6, 6 is here, -4, 6, 1, 6. Okay, this dot's going to be open because I have no line. 1, -6, 4, -6, 6, -6. Okay, so now we get the idea. Alright, there's my cute little graph. I love it. Alright, here you go. Number 7. Okay, table of values. X, Y. I have a shift happening at -2, where my two graphs are going to meet. So for my x values, I want to pick some numbers. -8, -4, -2. Again, -2, 0, 4, 8. Just to give me an idea of what the picture looks like. Okay, for the top ones, whatever x value I have, my y value is 0. And for the bottom ones, I gotta plug in my number. So, where's my calculator? Hold on. Okay, so now we have -2 times -2 minus 4, 0. Then we have delete 0. And we have 4, -12. And then again, oh, too far. And then we've got 8. So some of these don't fit on the graph, but you know, it's fine. We might have to pick some smaller numbers if we can't get a good idea. So -8 is 0, -4 is 0, and then I want an open dot, a -2, 0. However, this dot is going to be closed, so it's just a closed dot now because of the next half, because this guy is closed. And then we have 0, -4. Let's sneak another one in here. 2. -8. Okay, so like this. And then like this. There's that guy. So pretty. Okay, let's do another one. Okay, now we have 3 shifts. We have a shift at -1. We have a shift at 3. It's not necessarily a shift, it's just where we're looking at sections of the graphs. So from smaller than 1 down, we want to just have 1. And from -1 to 3, we want it to be this guy, -1. And then bigger than 3, we want this function. So, okay. I'm not going to put the top 2 on here because it's at 1 and then it's at -1. Okay? So that means that my line needs to be at 1 and then at -1. I just need to make sure I put in the correct dots. So over here, this guy needs to be an open dot because there's no line. Then at -1, he's a closed dot. but at 3, he is open. So it should look like this, and then like this. Okay. And again, if you're not sure, just like pick a number. So if I have -6 and my y value is going to be 1, so -6, 1, oh, it totally worked. And then the same thing here. Well, if I pick a number in between, like 1, well, then this has to be -1. Oh, do I have 1, -1? Yeah, I do. Okay, so I graphed it correctly. So now we're going to start here, and we need to start at our number, which is 3, and I get that these will be decimals, and that's fine. We want to keep them nice if we can, but if we can't, it's okay. So remember our pretty numbers with our square roots, so that would be 0, 1, 4, and 9. Well, I've already done past 1 and 0, but 4 is pretty, so we'll put 4 on there, and we'll put 9 on there too. And yeah, then we'll see what happens. So the square root of 3 is some sort of decimal. There you are. And then I'm going to add 2 to that. And I have 3.7. Okay, great. 3.7. Okay, and then the square root of 2 is, or the square root of 4 is 2, and 2 plus 2 is 4. The square root of 9 is 3, and 3 plus 2 is 5. So this worked out great. Okay, so right now I have a closed dot at 3.7. So we're going to go to 3, and then 3.7, so like almost 4. And then 4, 4, and then 9, 5. It's just a little bit off, like that. Okay, that's what that graph looks like. All right, let's do another one. Number 11. So again, our transition point is at -2, where we're going to shift from one graph to the next graph, one equation to the next equation. I'm just going to pick some smaller numbers, -8, -4, -2, -2 again, and then, I don't know, 4 and 8. Okay, over here I have -8, and then I'm plugging in here, so it's really -8 plus 1. Those two negatives make a positive, so it's 8 plus 1, which is 9. Then it's -4, so 4 plus 1 is 5. -2 is +2, plus 1 is 3. Underneath, I have a 4, so that's just what my numbers are. The top, this transition is open, and the bottom is closed. So -2, 4 is a closed dot. And these are functions, so you can only have one closed dot at a time on these up and downs. So I know the other dot has to be open. Let's just keep going. So then we have 4, 4, and 8, 4, straight across. Again, if you didn't want to write that in your table, I understand why. It's totally fine. Okay, then we have to graph this side, -8, 9. So -8, 9, I don't know, like here. -4, 5. And then we have -2, 3. Remember, this guy is open. And here we are. Okay, looks so good. Pen is really rolly. Okay, let's do 2 more. Let's just finish up. Okay, number 13. It's been a while since we've graphed exponential functions, but just remember that they get really, really big really fast, or they get really, really small really fast. So usually exponential functions kind of look like this. They have a flat spot called an asymptote that doesn't get, it continually gets closer to a number but doesn't go past it. Then they have this cute little curvy spot, and then they get really big really fast. So our transition is at -1. That guy. I just like the line because it helps me remember. That's all. You don't have to have it. Okay, so I'm going to pick some numbers smaller than -1, -8, -4, -1, and then -1. And then I want to pick small numbers because my line will probably look like this. It's a +3x, so it's not going to be flipped or anything. If this guy was a negative, then it might flip, so it'd be a little bit different. But I want to pick numbers that are kind of close because remember, exponents grow pretty darn fast. So I'm going to pick -1, I'm going to pick 0, 1, and 2. And we'll try that. Okay, up at the top, negative 8, negative 8. Or a negative 8 is a positive 8 minus 2 is 6. A negative 4 is a positive 4 minus 2 is 2. And a negative 1 is a positive 1 minus 2 is negative 1. Then here, we're going to type this guy in. So we have 3 to the negative 1, which is 0.3. Anything to the 0 is 1. 3 to the first is 3, and 3 to the second is 9. So I couldn't fit any more if I wanted to. It's already going to go off my grid because I only have 8 by 8. So negative 8, 6 up here. Negative 4, 2. And then this guy should be closed at negative 1, negative 1. Here. Oh, it's so beautiful. Oh, that wasn't. Okay, anyways. Now we have negative 1 and 0.3, so it's like there. It needs to be open. 0, 1. 1, 3. 2, 9. Oops, I drew that on the wrong spot. This actually needs to go up here. Like, this doesn't look right. Okay, sorry, my bad. Not this guy. This is not a thing. I'm sorry. It's up here. Okay, so then the exponent curves up and around like that. Because if you were to continue drawing it, it would like go flat here and then come across, and it wouldn't go below 0. So, my bad. I got confused with this cute little negative. Okay, so that's what that one looks like. And then 15 has 3 again. This one's a little bit more complicated, so we have a shift at 0, and 4. Okay. So I'm going to pick some numbers. Again, exponent numbers, which means I probably want to pick numbers that are pretty darn close. Yeah. Well, it's going to be an asymptote at some point. Anyways, let's just pick some numbers that are close to this line. So we'll go negative 3, negative 2, negative 1, 0, and then 0 to 4, and then 4, oops, heavens, 6, 8. I got a little excited with those cute lines. Okay, sorry. It should just be here. This is the middle section. So that section is here. Okay, so we're going to type this guy in. We have 2 to the negative third power plus 2, and that's 2.125. And then we're going to do that again, but to the second, negative second power, which is 2.25. And we're going to do that again to the negative first, which is 2.5. And anything to the 0 power is 1, and 1 plus 2 is 3. Okay, in the middle, it's just 3. And then at the end, negative 4 plus 4 is 0. Negative 6 plus 4 is negative 2. Negative 8 plus 4, no, it's just a positive 2. No, it's negative 2. Golly. Negative 6 plus 4 is negative 2, and negative 8 plus 4 is negative 4. Okay. Losing my mind. Okay, negative 3, 4, 3, and then 2.125, 1, 2, a little bit above. Negative 2 and 2.225, a little bit more higher. Negative 1, 2.5. And then this guy needs to be closed dot at 0, 3. So this is the asymptote, like that, straight across. In the middle section, we have 3's, so let's see, open and closed at 4. But I already have a dot here, so it looks closed. And then here I have another dot at, oh no, this one is supposed to be open. Okay, so at 4, 0 is open. and then 6, -2, and 8, -4, so this way. All right. Let me know if you have any questions. Good luck. Just be careful on your exponents because we haven't graphed those in a while. Remember, you have 4 different types. They look like 1, 2, 3, or 4. Okay? So this flat spot is called your asymptote, and it is whatever number is getting added to your equation. Okay, let me know if you get stuck. Have a great day, guys. Bye.